But no, for real.
All right, today we're going to talk about limiting reactants. Okay, we're going to talk about limiting reactants. This is a review from last year. One of the questions on last night's homework, I think number 7, had a limiting reactant problem. Okay, limiting reactant is exactly what it says it is. It is, pardon me, it is the reactant that limits the amount of product that can be formed. Okay, so like I said, you'll notice that sometimes your questions are worded to tell you if 15 grams of nitrogen react with excess hydrogen, how much ammonia is formed, okay? We don't have to worry about limiting reactant because it tells us that in that case, that nitrogen would have been our limiting reactant and hydrogen would have been our excess reactant. But today we're going to calculate our limiting reactant. We're going to calculate how much mass can be made. We're going to calculate how much of the other thing is left over. When you make things, do you necessarily want to have a limiting reactant? No, you kind of want to make sure you use the amount of each one that you need. Does that make sense? You know, I think like you're going to go make a cake, and you need 1 cup of sugar and 2 eggs. You're not going to put 2 cups of sugar and 2 eggs in it, are you? You're going to make sure they're going to equal out and you have the correct amounts. Okay, so this is review. All right, so limiting reactant determines which product made directly can you use that first. For limiting reactant problems, you must do 2 stoichiometry problems. You must complete 2 stoichiometry problems. The least amount of product that is formed, the smaller number is how much can be made. That makes sense, correct? You can only make as much as the least amount of stuff that you have. And then the reactant that gives you is the limiting reactant. The reactant that gives you that is the limiting reactant. And the other thing we're talking about today is the percent yield. The percent yield is usually determined how much products we obtain from the reaction. Very, 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 very rarely is percent yield 100. Okay, like some things a 30% yield is very good, and other things a 30% yield is very bad. So that had the reasons why on there. The equation is percent yield equals actual over theoretical. The theoretical, you can also word that into the stoichiometric. Okay, your theoretical yield comes from your stoichiometry problem. And that's what I think I'm just going from. Theoretically, that would form the reaction went to completion. The actual yield is what the chemist got. All right, so let's work out some examples of these. Let me pull up my paint. I'm sorry I did not have that prepared. Yeah, it's a Google Forms. You need to answer the questions, okay? And then you need to upload a picture of your work to it. Yes, ma'am. Yes, ma'am. Sorry. Stoichiometry test. All right, so we're going to do this problem first. All right, so here is our question, okay? Pain reliever aspirin is produced, and there should be a decimal point in this, I apologize, is produced by the following balanced chemical equation. C7H6O3, blah, blah, blah. If you mix 100 grams of each reactant, the first thing we're going to do is what mass of aspirin can be made, okay? So 100 grams of each reactant. So I need to do what? 2 stoichiometry problems, okay? And I'm going to put 100 over 1. So I'm going to have 100. It's already balanced up there. You're correct. 100 grams C7 H6O3 over 1. And then I'm going to have another one, 100 grams. Actually, let me put that a little bit higher up. So I'm going to use this whole page. I have another one. That's going to be 100 grams C4 H6O3 over 1. So I'm just going to begin We're going to work these together, but kind of separately. Zakiah, I want you to be finding the molar mass of C7H6O3, 158. I'm not arguing with it. How do you know that? This isn't off your homework. That's not propane. You're doing C. You find the molar mass of C7, and Lamaya, you find the molar mass of C4, H6O3. 100 grams C7H6O3, 100 grams C4H6O3. H6. Yes, ma'am. But you're doing the second one, which is the only thing that changes from the first one to the second one is the first one C7, the second one C4.
H what?
H6O3. It'll be like 84. Yeah, I want you to do the one with the C4. Let Zakiah do the C7. That way you can catch 138. 138 is fine. Okay. Now Zakiah be doing it for C9 also. Okay. Is it 102 or is it going to be 102? Right. So 102 is fine. 102 grams C4 H6O3. So I'm going to fill out these other stoichiometry problems. C 138. Not 138. Oh, sorry. And then my mole ratio, both of these is 1, correct?
It's 162. C9. 162.20.
She found the molar mass of the C9.
Oh, okay. Oh, so you want me to do the
Nope.
mass of C2?
Nope, we don't need that. We only care about C9. Okay.
And they go on both of them?
That goes on both of them.
Wait, what's the one?
That's the mole ratio. I just haven't filled. That's the mole ratio. I haven't finished filling it out.
So it's one, this, the bottom one, that one's on top, and that C9 thing on the bottom, right?
C9 goes on top. C7 goes on the bottom. And I'm not going to finish writing it out because I kind of don't have.
Adam.
Because here, C7's on the top here. So C7. My unknown goes on the top.
C9H8O4?
Yeah. I'm only going to write C4 and C9 because I ran out of room.
What's it, 162?
Yeah, not 168. I don't know why I wrote 168. I cannot wait for my smartboard to get fixed. This is a lot more difficult than it looks.
And then the bottom of it still be one.
1 mole, yeah.
C4 go on the bottom.
Nope.
They go on the top.
Nope. Both these are C9.
Right. Same thing back top.
Uh-huh. So Zakiah, I want you to solve out the top one, and Lamaya solve out the bottom. Okay. The bottom is made pretty close to 162. I'm gonna say it's gonna be like 158.
Bottom
My estimate's 168. 158. That's my estimate for the bottom.
top is 117.4.
So equals 117. So only need 3 significant figures.
158.8.
So 159. I'm pitiful. So this one, and I'm sorry, I ran out of room, equals, you said what, Zakiah? 117. And, yep. And what did you say it equaled, Lamaya? All right. So now I need to answer my question. Okay. What's the mass of the aspirin can be made? What? I need to answer A. What mass of aspirin can be made? I've done all the work. Now I just need to answer the question. Nope. Nope. The mass is whichever one gives you the smallest amount. So 117. Nope, not yet. That's only a percent yield. All right, B, which compound is the limiting reactant? Which reactant gave you the smaller thing? So C7. Yep. Right, C is the hardest one to do, okay? So on C, you need to start with how much can be made, okay? This is me. So on C, you need to start with how much can be made. So I need 117 grams of C9. I'm doing a stoichiometry problem. What's it? C9, H804.
Yeah, H804.
Then I'm going mass to mass. So I'm going from my aspirin back to my excess reactant, okay? Which one's left over? The C4 is left over, okay? So it gave me the bigger number. So I have most of the numbers already figured out. So I know the molar mass of C9 is 168 or 162. I don't know why I keep saying 168. I'm just going to write C9 in there just because 1 mole times 1 mole. That's
1 mole of what?
C9.
Oh, yeah.
1 mole C9. And I'm going back to C4. So the top of this one, my unknown is C4. Okay. Then I got to go, what would we say the molar mass of C4 was? 102. Over 1 mole. Yeah, put CO4 on the top because I'm going back to my excess reaction. I'm going back to the one that's left over. So solve that answer. No, I need 3 snippet figures. So 73.7. So let me find my equals 73. That is not my answer. Okay. That tells me how much is used up. Okay. That to make 117 grams of C9, I used up 73.7 grams of it. So now what do I need to do? Subtract. How much did I start with of it? How much of the reactant did I start with? 100 grams. So I would do, so to solve it out, how much remains is 100 minus 73.7. It would just be 26. But adding, subtracting, you only care about decimals. Okay. Does that make sense to you? C is what you struggled with last year. I'm 100% confident you could do A and B. Okay. On C, you use how much you made, okay, and you go back to the excess reactant, and then you subtract it from how much you started out with, okay? Subtract how much you started with. I'm gonna do another one though. Let me pull it up. I'm sorry. I was doing something else. All right, so here's gonna be our question. I'll make it a little bigger. And I'll have to write this down, then I'll have to work it out on another page, okay? So write your question down.
So you want me to write this?
Yeah, it's really not that long. I just made it really big. Good going up 2:30. Supposed to remind you to get the camera. Supposed to remind you to get the camera. No, you know Miss Taylor is. It's where Miss Reno was last year.
I don't want to go in there by myself. And I
You'd be all by yourself?
literally.
Nick's back. Nick. Really? What is it? Oh, thanks.
I have 8 years.
Now I know it says B, D, and E. That's because I marked some questions out, okay? And then I need to do percent yield problem. Yes, ma'am, it is.
Lots of right.
Oh, not as much as it really looks like, but yeah. Silver nitrate reacts with ferric chloride to give silver chloride and ferric nitrate. In a particular experiment, it was planned to mix a solution containing 25.0 grams of silver nitrate with another solution containing 45 grams of iron chloride or ferric chloride. They did? Good. Yes, ma'am. We've already beat them once. We haven't been playing very well.
I'm done with it. Did you write the question? You know.
All right.
Kanye ain't write the question, but I had to write it in.
You're an A student. She's not. All right, so I got to do 2 problems, don't I? So the first thing to do is stoichiometry problem. I need a balanced chemical equation, correct? So it was silver nitrate, correct? What was the equation?
Yes, silver nitrate reacts with
Plus FeCl3. FeCl3. All right, so now I need to balance this, don't I?
Wait, what is that?
NO3, 3. So to balance this, I put a 3 in front of this. So it's 3, 1, 3, 1. Correct? All right, so what were my masses?
25.0 grams of silver nitrate and 45.0 grams of FeCl.
So Zakiah, you figure out silver nitrates, and Lamaya, you do FeCl3. Oh, man, dummy. 45 grams. 45.0. Awesome. I just wrote FeCl3. I didn't write any mass down. What am I going to? What are you going to? What substance are you going to? No, over here. What am I looking for? What's the question asked for? You didn't write the question down because you're not prepared.
I got it. What I need to know.
No, you don't. You don't know what you're going to. Use this one. All right, hold on. Let me forget my numbers.
Because I don't know FE.
55.845. But you can use pass that. Pass that.
845. It ain't in like 32.
14.067.
Oh, 16.
What?
It's 14.067.
Mm-hmm.
No. 3 times 3, so 9.
9.
So it's 241. No, 42. This is a 0.8.
Hey, Zakiah wasn't doing what she's supposed to be doing. So will you please tell me what we're going to? So you got to kind of look at D, the maximum number of grams. You're going to AgCl. So Zakiah, figure out the molar mass of AgCl.
Oh, okay, so it's 169.
Yeah. 453.
I don't know. So it should say,
What? 43.
it should say AgCl, right? I don't know why I put AgNO3. No, that's right.
Because I'm asking how much of this I could make. So I got to fill out my mole ratios on this one because they're not the same. So I have 3, and then this is AgNO3, 3. This is Fe. Sorry, I've kind of taken a few shortcuts in my writing it out. I would take off points if I did this.
So just have one more AgNO3 or one more AgCl?
So what are you talking about? So I have 3 moles AgCl.
Yeah. So
This?
on top of 169, they just say AgNO3, right? No.
169? Yeah, grams. Yes, ma'am. Yes, ma'am. Yes, ma'am. And I just couldn't get it all written in there. So
And then the AgCl on top, right?
yes, of the next one. Yes, ma'am.
Wait, what is that?
143 grams AgCl.
Where did I find it?
Zakiah found that molar mass for us. Grams, just 143 grams AgCl. So Zakiah, you solving the top one out for me?
You did the bottom too? 146?
143.
Ah, yeah. Okay.
Same thing. Top one's 21 point, what? 21.153? So 21.2, correct? And what about the bottom one? Two 42?
I'm saying that's what
That number's 242. Yes, yes. But I'm saying
it's 82.9.
What's 242?
82.0 is not correct.
What's 242?
The molar mass of the one you
45 times 3 times 146.
divided by 143.
42.
Yeah.
82.0.
That is not correct. Find my phone.
Let me see.
That is not correct. You know, I know it. Oh, I guess it could be. I'm sorry. I was being dumb for a second. Confirm that, please. On my end. It could be correct. I apologize.
No, what's your MC? 82.
So 40,
I got 79.
45 times 182 times 143
Because my stuff is.
times 3 divided by 242. I got 79.8.
Yeah, 70.
I think you did 147 instead of 143, Sig High. So 79.8 is my answer here.
I really do not use calculator.
This is, I mean, who would ever thought it?
No, that's all this. No, like I said, and 7 and 3 would be the exact same.
They're both 3.
143.
They're both 143. Okay. All right. So my question is, what's the limiting reactant? That was the first question. That was A, wasn't it? What's the limiting reactant? What thing gave you the smaller number? AgNO3 is the limiting reactant. And what's the mass that can be made? 21.2. Now let's do C together. That's B, 21.2 grams.
A is this problem.
Well, A is AgNO3. You have to do the problems to get the answer. Okay. Mm-hmm. Yeah. All right. So C is
So B is
0.2.
So C, you gotta do what we start with.
No, it's not what you start with. It's what you end with.
No,
You got to start with 21.2 grams.
with the other one is 100.
Then we got to do another stoichiometry problem first.
Okay.
We got to do another stoichiometry problem first.
So you gotta do what you ended with. So we using the top right.
21.2
1.2.
grams AgCl over 1 times, we already know the molar mass is 143. No, 143. Ag's is 143. Because we're dealing with AgCl now. Because I made a 21.2 grams AgCl.
You said 243?
No, 143. Over 1 mole times 3 mole AgCl. That's AgCl. And what am I going to? Am I going to silver nitrate or iron chloride? Which one gave me the bigger number? So that's what I'm going to. So I'm going to FeCl3 because I used up all of the silver nitrate. So my mole there is 1 mole FeCl3 times 1 mole. And what we said, FeCl3 was what, 242? What's my answer?
I got 11.
I feel like you got 12.0, didn't you? So that equals 12.0. Now what I need to do?
You gotta minus that from the 21.
Not from the 21. 45. So 45 equals 33. That's 33.0 actually, but that's it. Okay. So last year we kind of struggled with this, and I'm going to work out one more type of problem. Let me find one. Last example of the day is not a limiting reactant one, just because I didn't want to work another one that was out. That should be an arrow. It has a question mark, but that should just be an arrow. Given the following unbalanced equation, how many grams SbCl3 are formed if 28.0 grams of chlorine is used? What? All right. Yeah. Tell me. You said hold up. That's all you said. Oh.
Then look, you want to put a 2 right there, put a 3 right there, put a 2 right
That's a,
there. Let's see.
I can't write right there for some reason. Yeah, you're right. 2, 3, 2. I agree with you. No, Quavo called me. All right. So, 232, she was correct. Now I need to do a stoichiometry problem first, don't I? So 28 grams Cl2 over 1 times, this is, I tell you that's 71 grams Cl2, 1 mole, where's the mouse? Cl2 times 3 mole Cl2, 2 mole.
Wait, what I'm going to? The CB?
Yep. SbCl. Yep. I know what you're saying. Yeah.
What's CB?
SB, I have no idea. I have no idea.
I need a thing.
SB is, and I give you one. I thought I handed one back to Zakiah to hand you.
No.
Antimony SB is 122. You use 122.
CL is 35.453.
453. You could have cheated and used CL as 35 and a half. 228. Sounds good to me. So let me find the mouse. All right, so what is my answer? I have 2 parts to this question. Here's the first part.
It's 60.
What, 60?
It's 59.9,
So 60 point grams. Not 60.0 because I only had 2 significant figures. Well, I'm dyslexic. There's nothing I gotta do. I gotta find the percent yield. What's the percent yield equation?
It's like theoretical of actual.
Other way around.
So actual of theoretical.
Mm-hmm.
Okay, so the actual is what we just found.
Nope.
So actual is what they give you.
Yep.
And theoretical is what you find.
So
it'd be 5. No. Actual is what they give you. So 5.0 over the 60. And you go time. It's 8.3. So is that right?
mm-hmm. There you go. That's the only other new thing for today. Like this is both review from last year, okay? But so that's where we are. Your homework is a Google Forms, okay? Make sure you upload a picture of your work.